CO spectrograph, but we still consider using further or doing some extra science with the eShel, and I came to learn about Demetra also.
Good, good.
Thank you. Frank, please.
Yeah, hello, my name is Frank. I'm from southern part of Germany, and I'm working at Sternwarte Feuerstein. It's a private amateur astronomical observatory here. I built it from the year 2000 up to now. We have many instruments up to 63 centimeters diameter. And before I did some work for space shuttle instrumentation, I built cameras which were shot up to the sky, or I have written software for the Hubble Space Telescope, for high resolution imaging and so on. And now we decided to buy a spectrograph. It's a eShel. But due to Corona disease, it was a little bit difficult to take data because I'm alone here. And I hope in the next it will change. I tried to get some spectra and I spread it to the community here. But actually, I'm trying to optimize hardware and software. Up to now, we used our own software. We processed the images by Fitzwork for getting better signal to noise ratio. And then we had our own software for taking the wavelengths and other parameters out of the spectrum.
Thank you.
Okay.
So I think other people will come later. We'll begin by Hugo because Hugo was part of a beta test team, so he will give the first feeling we have on Demetra, and after that, Francois will make a short presentation on Demetra. And I will be the timekeeper, so if it's too long, I will cut him, and we'll take the main part of this meeting for your questions. And in the end, we will conclude on some insight on the new versions of Demetra and your feeling about this meeting. Okay, so Hugo, please.
Yeah, so Alain asked me yesterday to give a short impression of my view of Demetra. And of course, that's positive. I consider Demetra as a new software of a new generation. And when I say that, I compare it with the existing packages for amateurs like VSpec, RSpec, BAS, whatever on one side, which are more or less user-friendly, but are lacking the automation of spectra. Then on the other side, you have ISIS, you have SPC or DAS, which is more or less automated, but which are not so user-friendly. And now we have both in one combination. That's one point. But more to that, there is a second aspect where everything can be done manually. And I like that. So you can go step by step, and it's a very easy learning process. So that's a very positive point for Demetra. I had another remark. I noted it down. So yeah, that's it basically.
Well, thank you very much. Maybe I continue. Can you hear me?
Yeah, yeah.
Are you okay, Alain?
Yeah, yeah. You continue.
Okay. Well, I will share my screen. Alain, I don't have the access to sharing the screen. I don't know how to do that. Demetra, I will have a very short presentation just to give a rough idea. We could spend hours and hours on going to the details, and there are many details to cover. But what we'll do today is really to have a general view of the software And and I think it's better that you ask questions on what is feasible or not, and so on. And maybe if we can start at the beginning with I would say general questions, not too much technical or detailed questions, to not misunderstand with everybody, or to not lose everybody. This software, in fact, when we see the history of Demetra, we started a long time ago, well, several years ago, and in fact we have released the LP version of Demetra, which was the first one. Is it okay now? Okay, yeah. Thank you. Okay. Now, if it works, you should see my screen. Is it okay? Anyway, it takes a few seconds usually. Alain, you tell me when you can see the screen.
On my screen,
it's okay.
It's okay. Okay, thank you. We started a long time ago, and really the idea is that we have quite powerful software packages, exactly like you said, Hugo, and some of them are very powerful. I'm thinking about ISIS, for instance, or Au-delà also with the SPCODES module. But they were not very user-friendly first, and also what is the complex is that these are usually very universal software, and when we use it for a dedicated instrument, it's not that easy. And well, in fact, we did have a wonderful module, eShel module, in the Au-delà software. At the beginning, and it still works, and this is still the official version today. But the problem with Au-delà is that this software is not supported anymore, or the team working on it is really too small to have something very active. And well, by the way, we know that when this Au-delà software was created a few years ago, the decision was made to use the TK language. At this moment, the Python software were just arriving. It was too young tool to do it. So we made the decision to go to TK, and that's a pity, because I'm sure that if Au-delà was based on the Python, today it would be the reference software for all the astronomy. But that's life, that's it. And now we have a lot of users using Python, and TK is not very used. Anyway, so we really need for our instruments to have a software that's really manage the whole instruments, make something easy. So for me, it's very important that this software must help us and during the observing night. And in fact, I had the experience that doing spectroscopy is interesting. It is fun, but the acquisition part is interesting, but the data reduction part is always complex and boring. And we really wanted to have something very easy to use in the field, and something that helps us from the acquisition to the data reduction. So one of the big difference between Demetra and the other software packages is that Demetra is really dedicated to given instruments. So LP, we are working also on the LISA version for Demetra, and now the eShel, which is still in beta version, but it's working better and better, and we will release this version in few weeks or months, I hope. So because it is dedicated to one instrument, the advantage is that we have in front of us exactly what do concern our instruments, and it helps us to use the instrument. Something which is also very important for me is that the eShel, the software now is part of the instrument operating mode. So we for a long time we did sell with Sheliak, we did sell instruments and saying, well, we sell the hardware and just do your best with the software. And now we really want to have something embedded with the software, and through the software we can help the user, the observer, to use the instrument properly, and to make this observation easier and easier. Okay, so So when if I show you quickly with the demo image that are embedded in the eShel software, this is a short presentation. When you start it, you have two buttons, mainly two buttons, the Manage Observation buttons and the Take Spectra button. Sorry. So the Take Spectra is used to connect to the eShel. So for this demonstration, I don't have an eShel connected right now to the instruments, but the idea is really to have something to acquire the image, and you will see that this acquisition module is very connected to the observing manager module. Okay, so when I click on this button, manage observations, so we open this window, and the first important thing is that here we have the list of the observations. So here I have only one observation of the sun. Again, this is the demo image, so you can play with this data when you when you download the software. And in this, when I look at this observation, I have different tabs. So this is the first important thing. In Demetra, we are not talking about images, but we are talking about observations. And an observation is a consistent set of images that are defined in this observation. So we have 4 tabs here. The first one is for the definition of the object and the context of the observer. So the name of the observer, the observation site, and so on. We have the second tab, which is I would say the image collector. And in fact, we have different baskets with the different images, kind of images that we need to run a proper observation. For instance, we have the object basket, and I see here all the images. And I can double click on any image, and then it appears in the bottom part here. It appears in the screen in the bottom part. So I can look at any image. If I look at my dark images, for instance, I can just double click on it, and then I can see it in the bottom part of the image. And the blue area is the position of one of the order which is displayed here. So, and I can move, of course, through the different orders. And well, one of the big advantage of doing this, I can also extend the image horizontally to have a better view of the image. And one of the advantage of doing this is that I can use this show profile tool to see the profile in real time. Okay, so I do that. Of course, this is some images that I've recorded some time ago, but we can do exactly the same in real time during the observations. Okay, and then I can move from one order to the other, and for instance, we can see here. I guess this is the sodium doublet at this position. So I can move from one order to the other. Okay, so I have to do a proper observation with Demetra. We have to collect the image of the target, the image of bias, of dark image, flat images, like this, which is a common continuous lamp. And we also have to have the calibration images. Okay, so and the calibration is made with the thorium argon module most of the time with the eShel. Okay, so an observation is a consistent set of the images that is summarized here. And well, by the way, if I remove one of the image set, for instance, I cancel this image, I see that immediately the basket becomes becomes red. So it means that something is missing in the observation. This is interesting during the night. So to be sure that you are not forgetting any image during your observation, you can know that if your observation is green, so it means that you have collected all the information. Okay, and normally I can re-add. No, I have to, well, in this case, I have to put the images. These are the calibration images. Here they are. Okay, and so I've added the calibration image, so the observation becomes green again. Okay. well, I forgot. Oh, yeah, see, just something here which can be important. Here I use this add button. So I just took the existing images on the hard disk, but I can also acquire my image, and this will switch to the acquisition module. Okay, and then in this acquisition module, sorry, I have to remove the zoom windows. You can have the control of the camera, and you can have the control of the calibration box. So you can have something very automatic. And you see here that I can click on this button to go back to the observation. And because I'm working currently in the Sun 1 observation, when I go to the acquire module, it's set this observation in this position. So it means I can do directly from here my acquisition, and the data will be sent directly to the basket. Okay, so this is something very very easy. And of course, during the acquisition, you will be able to see in real time the different orders of your observation. You will have a saturation detection. You will have some tools like that. You can control the temperature of your camera and so on, and check that everything is okay. Okay. That's it. And what is very important also is that because we have collected the right images and given the right parameters to Demetra, then the data processing can be very, very fast and easy. Okay, in this data reduction tab here, you have the list of all the steps that's through through which you have to go to properly process your data. But of course, the idea is that once you have, so I recommend for the first time to do it really step by step. And for instance, for the bias image, click on the run button to generate the master. And you can see here, for instance, you can look at the image at the beginning. And if I do that, I see my image in the bottom part. And if I click on the right part, I see the result of the operation. So this is the raw image, one of the raw image. I can move I can move through the different images here, and I see the result of my operations. In this case, we can see that the master offset, master bias, is less noisy than the raw images. Okay, and you can do the same for any step in the process. But the normal usage when you have done this is to go through the data reduction process, just click on the run button, and it will do all the steps in sequence. And at the end, you have directly the result of your observation. Okay, so it will take a few seconds. It is slower when I'm working with Zoom, because I guess that the capacities of the computer are used, but anyway, we can see here. So you have the geometry correction to correct the slant angle if necessary. The extraction is the fact that you extract all the information for a given order to transform it to a profile. You have the stacking operation to stack the different profile, the blaze correction. You have the calibration detection and the calibration, which are two different steps, and the calibration is totally automatic. Okay, and so it is doing right now the calibration detection. You can see the result of the real-time operation, and you can see all, for instance, all the RMS for the calibration, wavelength calibration for each order. Of course, at the end, this log file is kept. So if you don't read them fast enough, you have the data at the end. But when it is finished, here is the result. And now, again, I can move across my different images and see, for instance, so this is, this is the calibration. The sun result, again, sorry, this is this one. The sun should be here. Thank you. For the order 34, the one with the H alpha in the eShel is this one. So we can see H alpha at this position. Okay, and well, I can go to I was in the intermediate image. I can see the result here. Sorry, this is after the correction, and in this case, it is in wavelengths units. So in this case, we can see that the H alpha is at the right position. Okay, if I measure it, I see that the result 6 6562.8 is a very good value for the H alpha. Okay. So when we have finished this operation, again, this is very automatic because the parameter have already been set. But we the first time we have to go step by step, and in some cases you have some tools to help you to set the proper parameter. So you have to do that. The first one you work with the eShel, and then after that, if you don't move anything in the instruments, all the parameters will be the same, and then you can take all your time for your observation, and you have the result very fast at the end. Okay, and the last tab here is for the output. So you can see the result of all the orders. So one of the things that we have to add is to add the order number to know where we are. But we have a good indication with the color. So we are in the red part, for instance, here, and we can see. Well, I guess this is the H alpha. So this is the order 34. Okay, so I think that is for this short presentation. It's a quick overview. The idea is really to have something very automatic from the acquisition to the data reduction, and very embedded and very also useful. So I mean, for instance, all the data of your observing session are all collected in a single folder. So you can always explore the folder and see what are the images, where it is. Yeah, it arrives. Sorry. Oh, it's so slow. Okay, so this is the folder of the session. All the fits image are purely fits images. Okay, so there is nothing added in the image that make a special format. Or no, there are only fully standard format. All the information you have, for instance, regarding the observation of the sun, is in this file, which is the sun.ops file. This is an XML file, so you can look at it, and there is no secret. I mean, there is no closed format. And I can see also that we have a subfolder for this observation, and you will have here all the intermediate images that are generated during the process. But these are not necessary for the observation. So we have now moved these images in a subdirectory. So I can, because they are intermediate images, I can really just cancel or erase this folder, and that's it. Okay, well, maybe I will stop here to have your first feedback and see. Well, Alain, you didn't stop me, so maybe it's not too long, or your mic is closed. And
my mic is open, and I was going to stop you. So, any question on the presentation, or in general on the software?
Wow. Oh, I see
Yes,
that.
You showed that there is one dark frame. Is it the same for image and calibration files?
Sorry, I didn't understand your question. About the dark?
At the beginning, you showed a dark image.
Yes, like this.
Is it the same for flat, calibration, and object?
Well, I can do the same. So if I click on the flat basket, I can double click on any image, and I see the result in the bottom part of the screen. Okay, and I can really play. I can play with the image and so on. So I can zoom. And is it your question or not?
No, my question is a little bit different. If object exposure time is different to flat exposure time, do we need different dark images?
No. Well, okay. Sorry, I understand your question. In this process, we use only one dark, and when we do the calculation, the data reduction, we interpolate the duration of the dark with all the different images. So there is one condition for the dark images, is that it is at least as long as the longest image in all the baskets. Okay, so it means that if you have an observation of a faint object that lasts for minutes, then you have to have darks that last for minutes. Okay, now if you have a short exposure time, a few seconds, because you're just looking at Vega, or I don't know why, and in this case, usually this is the calibration image that gives the minimum dark duration.
Okay, thank you.
Okay.
I have another question about that. That's most of the time bias and dark are standard files that will last for months before you need to change them. Is there any way that you can use those automatically, the default files as bias and dark, instead of always adding them to the folder?
Sure. Sure, this is important. Yes, bias and dark we usually do libraries of images because, well, offset bias images are short, but dark images are long to take, so it's boring. And of course, when you fill your basket here, you have two ways. Either you acquire your image, or you can collect them from your hard disk. So if you are in another folder, you have your dark library, you just have to click on the add button, go to the folder you have your dark, and then Demetra will copy these dark images that you'll use in the session directory to make sure that we keep all the original data in the same folder. Okay, and by the way, if you have already made the masters, because you did a lot of images and you did a master of the image, you can just put one master in the image and put only one image here in the basket, and that's it.
Okay.
Well, I see Michael Engel. That's great to see you.
Quick question, Francois.
I'm unmute the microphone. First of all, it's really impressive after using a long time the Odela. This is a great step, a huge step towards automatic analysis of eShel spectra. Due to technical problem, I missed the first part, but so maybe my question is redundant. But what is the interface with the camera or with the hardware? Is it easy to interface any camera with this?
Yes, absolutely. You just have to click on the acquire button or open the acquisition module, and here is the interface for the camera. So you can select the exposure time, the number of images, and so on. And well, of course, you can have some preview of the images. And you can control the camera itself, so you can select your camera and select the temperature target and things like that. Even you can crop the images if it is useful. So you have all the parameters for the camera here, and you also have all the parameters for the calibration module here. Okay, and we have the different functions, so I can control manually and say, well, I put the calibration module to the dark position or to the flat position, so it will switch, it will control the box directly. And you can even open this combination window that says, okay, when I click on the dark, on the flat, for instance, I open, I am in this, well, I'm in the flat here, I am in this configuration, so I switch the relay number 1 and number 4, so everything is tunable, easy to tune. And by the way, we can add something important also. So when I go back to my observation, and again, I told before that when you do an acquisition, so it will fill automatically the Sun1 basket here. Okay, so it will put the data in the flat basket here. Okay, and by the way, you also have an acquire sequence here, and in this button, you can do an automatic acquisition of your dark, bias, flat images and all the reference images that you have in the beginning. Okay.
Great.
Something also. Well, I guess does it reply your question?
Yes, any ASCOM camera can be connected to this.
Yes,
so it's
yes.
ASCOM standard camera.
Yes, this is the rule for us. We only support the ASCOM cameras because today all the cameras, all the serious cameras have an ASCOM driver.
Okay.
Okay, so at the beginning we did connect directly to ATIC or SB cameras, but we stopped doing it, knowing that well, now we have an ASCOM interface, and that's very good. Something important also is when I've done my first observation, if I want to do a second observation, of course, the bias, the dark, the flat, the calibration image maybe will be exactly the same. So I can do a new observation here and say, well, this is the second observation. Sorry, observation 2. No, I cannot put a interesting. Okay, this is a new observation. In this case, it will be red because all the baskets are empty. Okay, so you can take time to try to put the file, but it will take time. So it's much better to right click and do a copy, or click on the copy button here, which is the same. And then here I can select in my new observation, for instance, so the G observation, I can select which baskets I will reuse and which information I will reuse. So if I do a new observation of the sun, I will keep all the new elements, and then the new observation is filled with the same data. Really, again, to save time, and then I just have to select to acquire my target images. Okay.
The user interface is really good.
Yeah, well, I know that Michael, we spent a lot of time talking about Odola. For me, one of the big difference between Odola from my technical standpoint, the big difference is now we fully have the control of the software. Okay, and with Odola, it was not the case, and it was something complex. Well, what we did, I think we did a very good job a few years ago, but the problem was the maintenance. Now, if we have a problem, we can solve it. And for me, it's very important that Demetra will evolve over the time based on your needs or your feedbacks, and now we can do it. In fact, it was not the case for the Odola.
Something we didn't talk about yet is about instrument response correction, because for that you would need a stitched together spectra and work from there to get an instrument's response. Is that already working, or is it still in progress?
Yes and no.
Yes and no.
It works. So in the process here, we have a response step here, and we can activate or not. Okay. So the way to process, the correct way to process is to say if I select the response curve correction, then I have to select which response curve I will apply, and if I don't have yet this response curve, I can construct it. I can build this response curve with this tool. Okay, so in this case, I can select in this case, I have to rerun all the process to have the image, but I'll do that in background. Okay. Sorry, but we have all the tools to build the response curve, and then after that to apply it. Now, the part of the answer which is no is that we know that we still have to improve this part to have something easier to do, especially because in this case you have to work with all the orders separately, which can be very long, in fact, so we have to work to merge all the orders and to have only one response curve for the whole instrument. But so this is what will work in coming weeks or months. Okay, but the idea is to have everything embedded, but of course you still have to build your response curve, and to do it, you have to observe first a reference star, so which is a star, usually a hot star with the Balmer lines and a smooth profile, and for which you have a reference spectrum, for which you are confident this is a good reference.
Yeah, but they're most of the time they're a full spectrum, not just in orders. They go from 4,000 to 8,000 as a whole, and not in small parts. the references.
Absolutely. Anyway, the way it is made, so you can do it very manually. So we can change. Well, we see how we do the interface, but you can really select the response curve for any order if you want separately. So this is something which is important. The Demetra, for me, this is the tool that helps you to provide a good scientific data at the end of your observation. Okay, so